Perspective Class 7 Video 2. In this video we're going to talk about parallel projection from three-dimensional space onto two-dimensional space. So let's go straight to the definition. The definition is in three parts depending on to which plane you want to be projecting. So parallel projection onto the x equals a plane sends the point xyz to the point ayz. Parallel projection onto the y equals b plane sends the point xyz onto the point xbz. And finally, parallel projection onto the plane z equals c sends the point xyz to xyc. Okay, so again, it's very similar to the two-dimensional case. If you parallel project onto the plane defined by x equals a, you just replace x with a. If you project onto y equals b, you replace y with b. And finally, if you project onto z equals c, you replace z with c. That's it. One thing I want to note is we call the plane onto which we project the viewing plane. Okay, so for example, in the first part of this definition right here, you would say that the viewing plane is x equals a, and in the second line you would say the viewing plane is y equals b. It's the plane onto which we project. So if you imagine like the plane, this is like the canvas onto which we're going to draw the representation of the three-dimensional object. Okay, so that's the viewing plane. So let's look at the geometric interpretation of parallel projection in 3 dimensions. So here's an example. It's 3 dimensions. The plane, the viewing plane in this case is y equals 2. Okay, and there are 2 points, and I parallel project them onto the plane y equals 2. All that means is I draw this line, this arrow, which is going to intersect the viewing plane perpendicularly. Okay, so it's going to be perpendicular to the viewing plane. You can't see that. It's going to be perpendicular to the viewing plane. And that's what happens under parallel projection. So this point here ends up down there. This point here ends up down there. Okay, it's exactly analogous to in 2 dimensions, but it's just harder to draw. So let's move on to some algebraic examples. Parallel project the following points onto the x equals 1 plane, and then sketch their image on the x equals 1 plane. So here are the points, and if I parallel project the first point, I get 1, 3, 0. All I'm doing is I'm replacing the x coordinate with 1. Second point gives me 1, 0, 4. Third point gives me 1, 1, 1. Nothing changed in that case. And the fourth point gives me 1, 4, 1, like this. So this is the result of applying the parallel projection. Now it asks me to sketch them. So I'm going to draw a copy of the x equals 1 plane. That's what I want this to be. Okay, so that means that the coordinates are not the x and y coordinates. Now they're the y and z coordinates. Okay, because this is a copy of the x equals 1 plane. That's how I want you to think about it. What I'm drawing is a copy of the x equals 1 plane. And now I'm going to sketch these points. Okay, well obviously these points, they each have 3 numbers. They each have 3 coordinates. But notice the first number is always 1. The x coordinate is always 1. And I'm assuming that this plane is the x equals 1 plane. So what that effectively means is ignore the first number, and you're going to plot the y and the z coordinate. So for example, this first one is just going to be 3, 0. Right there. The second one is going to be 0, 4. So 0 in the y direction, 4 in the z direction. This one is going to be 1, 1. And finally, this one's going to be 4, 1. So that's 1, 2, 3, 4, 1. Right there. Okay, so this is the plotted image of these 4 points on the x=1 plane. When you're doing these sort of questions, it's very important that you label your axes and also try to be consistent. So I like to always label them like this. If it's a YZ coordinates, then I always put Y like this and Z like this. Okay, that's the end of this example, and that's the end of this video.